This is Section 3 of the Water on Earth Reader, pages 30 through 35. Problem of water pollution. The Everglades. During half of the year, part of southern Florida is covered by a slow-moving river. This river is filled with sawgrass marsh, so it is often called the River of Grass. This river is part of the Everglades, a region of tropical wetlands covering 1.5 million acres of land. Wetlands have three defining features, which connect all of Earth's systems. 1, they have the ability to hold water, hydrosphere. 2, they have moist or wet soil, hydrosphere and geosphere. And 3, they are home to water plants, hydrosphere, geosphere, and biosphere. The Everglades are an important part of the water cycle. Because of their location on the coast of the Atlantic Ocean, the Everglades experience strong thunderstorms and sometimes hurricanes. These storms provide abundant water that cycles through the region. Part of the water cycle. There are 2 seasons in the Everglades, a dry season and a wet season. The dry season lasts from December to April. The wet season lasts from May to November. During the wet season, the Everglades become a river that is shallow but miles wide. It moves so slowly that it is almost impossible to see. Life in the Everglades depends on this natural cycling of water. The wetlands play another important role in the water cycle. They improve water quality because they act as natural filters. Filtration is the process of separating solid matter from a fluid by having the fluid pass through the pores of another substance, called a filter. The Everglades act like a strainer. As water moves from Earth's surface through the Everglades, it is filtered, becoming purer. For example, some plants in the Everglades take pollutants into their roots and change them into less harmful substances. By the time water has moved through the Everglades, many pollutants have been removed. Environmental threats. But the Everglades face many different environmental threats. An environmental threat is anything that can cause harm to the environment. For example, scientists realized that human activity was causing so many pollutants to enter into the water that the Everglades couldn't filter them all out. This goes back to the water cycle. As rain falls, some of the water is absorbed into the ground. Whatever doesn't absorb into the ground or get used by plants and animals can become storm water runoff. Runoff happens when water, along with the substances carried in it, flows from the surface of an area of land, a building, or structure. This runoff carries with it sediment from the ground, as well as bacteria, fertilizers, pesticides, oil, and other contaminants. In recent years, scientists have focused on conserving the Everglades. Conservation is the weighing of human needs against the needs of the environment to create a sustainable way for humans to live off of natural resources. Conservation comes in many forms. In the Everglades, it has included setting aside some of the land as a national park and cleaning up polluted rivers. Engineers solve problems. Teams of conservation scientists and engineers are working on the problem of water pollution in the Everglades. Engineering is different from science, although science and engineering are connected. Scientists use experiments to gain knowledge. Engineers use that scientific knowledge and mathematics to solve problems by creating new technologies. Similar to how scientists follow a scientific process to answer a question, engineers also follow a process. Engineers often follow a process with 8 steps that guides them as they create new technologies to solve problems. The engineering process begins with a problem. In the Everglades, one problem was water pollution that harmed the surrounding environment. When engineers are defining a problem, they include the criteria. The criteria are the needs the solution must meet. They also include the constraints. Constraints are ways the solution is limited. Materials and cost are two common engineering constraints. Once they have identified the problem, engineers need to research it to find out what is known about the problem. For example, engineers researched where the main sources of pollution in the Everglades were coming from. They realized that much of the pollution came from fertilizers used by farmers and polluted stormwater runoff. They also researched the filtration benefits of the Everglades. For example, engineers need to know that porous materials allow water to flow through them easily. They also need to know that some materials filter water better than other materials. After engineers have researched their problem, they survey the available materials. This survey includes a sketch of the material, as well as how much of the material they have available and the properties of that material. For example, engineers need to think about the porosity of the materials they are planning to use. The smaller the pore size is, the purer the water will be that flows through it, because everything that cannot fit through the pores will be filtered out. Engineers then come up with possible solutions for how the problem can be solved with the available materials. For example, many communities use filters made of sand, gravel, soil, or other porous material around storm drains to treat stormwater runoff. As runoff water enters the storm drain, the filter can strain out pollutants before they enter the storm drain. This solution helps to prevent pollution from becoming part of the water cycle. Engineers then diagram and build a prototype. A prototype is a scaled-down first draft of a technology. Once built, engineers test the prototype. They use the test to gather data, which are measurements and observations that capture how well the prototype solves the problem during testing. Engineers who want to know how well their storm drain prototype filter works test it to see how many pollutants it filters out before the water reaches the Everglades. Finally, engineers use their data to decide whether to refine or replicate their prototype. The data tells engineers how well their prototype technology solved the problem. This is the engineering design process. Similar to the scientific method, it includes the steps engineers will follow and consider in order to create a new technology. The steps don't always go in order, however. They do begin with a problem, followed by research and a survey of available materials. Possible solutions, diagram and building a prototype, and testing may lead engineers to go back and survey additional materials, or to consider other possible solutions. All engineers will collect data and make a decision whether they should refine, basically try again, or if they are satisfied, they will replicate their new technology.